All right, so homework 28 is talking about odd and even functions to begin with. 4 functions are depicted below, 2 as graphs and 2 as equations. For each function, either the function is defined explicitly or the entire graph of the function is shown. It just means that it's not a partial graph, it's shown the whole graph. Decide whether each is an even function, an odd function, or neither function. Well, in order to be an even function, you have to be able to split it right down the y-axis, and it has to be the exact same thing on both sides. If I fold it over, they touch each other.
Okay.
So, this is going to be an even function because if you look on either side, they're mirrors of each other, right?
Yeah.
So this is even. Now the next one, if I try to split that right down the y-axis, notice they're not exactly the same on both sides, right? Because this one would have to start going back up right here so that they'd be exactly the same across from each other. So it's not even. In order to be an odd function, what they have to be is diagonally across from each other. Again, this one's not going to be diagonally across. Remember when we did those those cubic functions that went like this?
Yeah.
Those are an example of an odd function.
Okay.
So this one here is going to be a neither function. Neither. It's not even, it's not odd.
Draw that line?
So you don't need to draw that line in there. I was just giving you an example of what an odd one would look like. But an odd one is diagonally across from each other. That's what you want to think about when you look at the graph. Now, when they talk about looking at the equation and you're doing an even or an odd function, if it's an even function, it will have all even exponents. And a constant term counts as having an even exponent because it's to the 0 power, and they count 0, 2, 4, 6, 8, all as even, right? So if it has all even exponents, it's even. If it has all odd exponents, it's odd. So this is an example of an even one. We have to the 4th, to the 2nd, and to the 0, all even exponents. This is an example of an odd one, to the 3rd and to the 5th, both odd numbers. So, number 2. Do you think that one's an even, an odd, or a neither?
I'm thinking it's even.
Nope.
Nope.
Because if it's even, what do we have to do? We have to be able to split it right down the y-axis, and it has to reflect across that. So it has to go like this.
Oh, okay.
Okay?
So this is.
Oops. Didn't want that to happen. So, it's not even.
So is it odd?
Is it odd? Now an odd one has to reflect across the diagonal here in the middle. So in order to be odd, it would have to be right across the middle, and it's not, right? So this is a neither. Now number 2, what do you think number 2 looks like?
Number 2 is an odd.
Is an odd, yes. So here, what they technically say is if I folded it over here and then folded it back down, it'd be right on top of each other. If I had a piece of paper and I could fold it, first it would go up like this, and then I'd fold it back down and it'd touch. But if you kind of look at it, it's diagonally across that middle, it's right centered in there, and each part as you go would be opposite of each other, as my board wants to hop all over the place. So yes, that is an odd function. How about this equation, f of x equals 2x minus 3? What's that mean?
I'd say neither.
That is neither, right, because this has an odd exponent, this technically has an even exponent. So it's going to be neither because it has both. How about the 2x squared plus 4?
It's going to be even?
That is even, because remember this means I have x to the 0, and 0 counts as an even number. So it has a 2 and a 0. Both of them are even. Okay, so number 3, if you look at that one, is that one even, odd, or neither?
It's going to be an odd.
It is going to be an odd. How about the second one on number 3, that other graph?
That is going to be, I'm going to say neither.
It is neither, exactly. In order to be even, this would have to be right in the middle, and then it would be an even function. But if it's not right in the middle, it's not going to be either. All right, now, this one here is a little different than the previous ones because it has those parentheses. If it has parentheses or a square root or some other weird thing, we can't just look at the exponent. What we actually end up having to do is do a test on that. So what we're going to do is we're going to test, and you could use the test on all of these functions, but usually it's just quicker to look at the exponents. What we're going to do is test the values of 3 and negative 3. If we get the exact same answer, it's an even function. If we get opposite answers, it's an odd function. And if we get 2 answers that have nothing in common, it's a neither function. So we're just going to plug in the 3 and the negative 3 and solve these. So I'm going to have negative 3 minus 4 cubed. And then you're going to plug that in, see what number you come up with when you use your calculator. Unless you want to do it on your paper. You don't have to use your calculator, but you can.
So I do parentheses and parentheses again?
Yep, because the parentheses here are in the problem, and the parentheses here is because you put a number in for the x.
Okay, so what number you want me to give you? The negative 343?
That's what you got, negative 343. Okay. Now we're going to do it, and instead of using 3, we're going to put negative 3 in the parentheses. So we're going to have minus negative 3 minus 4 cubed.
That's one is negative 1.
That gives you, okay, negative 1. Would that be even, odd, or neither? Are they both the same? Are they opposite of each other? Or they have nothing in common?
I'd say nothing in common.
Nothing in common. So it's going to be a neither. So just for fun on that second one, we can look at that one. Is that one an even or an odd function or a neither function?
That's an even function.
That's an even function. But if we didn't know that, we could do this same test. And just to show you what's going to happen with an even function, we're going to test this one.
Okay.
So if I'm going to test it, I'm going to start and I'm going to put 3's in. So I'm going to have minus 3 to the 4th power minus 4 times 3 squared. Right? In parentheses for each of my x's, I'm going to put my 3 because that's my test value.
I got negative 117.
Negative 117. Now we're going to test it by putting negative 3's in the parenthesis. So we're going to have minus in parentheses negative 3 to the 4th minus 4 and in parentheses negative 3 squared.
That came up with negatives.
117, right?
Yeah.
So there's an example. If it was an even function, you get the exact same answer. Like I said, the only time you really have to test it is if you've got parentheses or square roots or something strange. As long as you have a plain linear one, you don't really need to test it. You can just check the exponents. But if you're not sure, you can always test it.
So am I gonna when I test them, am I gonna always put in negative 3 or?
Positive 3 and a negative 3. Yep, those are the values you're always going to test with. There are different ones you can use, but those are the easiest ones to use.
Okay.
So those are the ones I suggest you test with. So, even, you'll have the same numbers. Odd, you'd have opposite. So one would have come up to 117 and one would be negative 117 or something like that. Neither, you just get nothing in common, just 2 random answers. So that's how you test if you're not sure if it's even or odd.